Alright, welcome to my problem 4 week 9 video explainer. So in this particular example, there's a beam of light that is incident on a glass near boundary, and I drew that under. And we're going to take the index of refraction to be 1.39 for glass, and the index of refraction of air to be 1. So N1 is going to serve as the index of refraction for glass, and N2 being that of air. So in the first part of this problem, we are going to try and to find out, so if the angle of incident light with respect to normal is 45 degrees, what is theta 2? So theta 2 is going to be the angle of the transmitted light, and so theta 1 is be the angle of the incident light. So we know that we can relate the angle of incidence and the angle of refraction and compare their respective refractive indexes from Snell's law. So we're going to have sine I, which is going to be the angle of incidence, and the angle of refraction. And that angle was given as 45 degrees. So ultimately, we're going to end up solving for that theta 2. So we know that the angle of, or the refractive index of the glass was 1.39 and so of N2, and N1 was 1, being the refractive index for air. And we were given that the angle of incidence was 45. So we take sine 45 and multiply it by that ratio to give us 0.9828. And we can take the inverse sine of that ratio to give us theta 2, which is going to be the angle of the transmitted light, which we find out to be 79.357 degrees. For part 2, we are trying to figure out how large would the index of refraction of the glass have to be for total internal reflection to occur for theta 1 equaling 45 degrees. So similarly, we're going to set it up where we have so this angle of okay, well, let me backtrack it. So same thing from Snell's law. We know that we can relate the angle of incidence and the angle of refraction with the respective refractive indexes. So we're going to have sine 45 over sine 90. And now if we're trying to find the refractive index of glass, we are just going to do 1 over sine 45, which we find turns out to be root 2, which is 1.414. So that would be the refractive index of glass for total internal reflection to occur. So this just relates to what we've been doing in class. I guess just in regards to using Snell's law, and some of the tricky parts, I guess, probably for B was interpreting the total internal reflection to occur. But yeah, once you know that you can just essentially use Snell's law for both of those, then it's really not that complicated. And yeah, so thank you for watching the explainer.